Hello again, welcome to another video on the review part that will lead the way to our going to calculus next semester. Today, one single topic on the agenda, analytic geometry. That is the study really of what happens in the Cartesian plane when you have a couple of points, you can get a line, you can get midpoints, and you get stuff like this. Not a very difficult topic. So let us give ourselves what we need to actually work. So let P with xy coordinates be x1, y1, and Q, x2, y2 be 2 points in the Cartesian plane. In the Cartesian PTS points be 2 points in the Cartesian plane. Well, the first thing that I want to talk about here is the line, right? The line that actually passes through these 2 points. The line through P and Q, smudge, 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 P and Q is pretty much always given by, there are other ways of writing this, but the most common way to write the equation of a line, you know, is y is equal to ax plus b. Yes, of course, where a is the slope, a is the, oh, that's such an important word, we're going to give it a different color. S is the, A is the slope of the line, and the slope of the line, as you may remember, is delta y over delta x. That is difference of the y's over the difference of the x's. So y2 minus y1 over x2 minus x1. We also have another component in the equation of a line. It's the b part of it, so ax plus b. This is the, you remember that? What is b? What does it stand for? The y-intercept. Yes, it's the y-intercept. In French, l'ordonnée à l'origine. And the y-intercept, that is actually when x is 0. So it's the point where the line crosses the y-axis. Good. So a couple of notions that actually pertain to the line as well. Two lines that are, another key word here, parallel. Parallel. Two lines that are parallel have the same what? You know this. Two lines that are parallel share the same slope. That is correct. Have the same slope. Absolutely. And I guess I'm pretty easy to read. It's easy to figure out what I'm going to say about the next here, because if we talk about parallel lines, we should also talk about, perpendicular lines. So two lines that are perpendicular, strange word. You might also have heard the word orthogonal, means the same thing as perpendicular. Have slopes that are what? They have slopes that are what? Negative reciprocal of each other. Have slopes that are negative reciprocal of each other. Negative reciprocal of each other. What does that mean? It means that if one line has slope of 3, then the line perpendicular to it will have slope of the negative reciprocal of 3, which is minus 1/3. Yes, absolutely. All right, so these are the basic notions. We can start working out problems using this. So let's make room. All right, I think I spent more energy pushing on that rag than actually writing on the whiteboard. Example one, I think 2.5 stars should fit the bill for this one. So suppose that we have 2 points and we want to find the equation of the line through these 2 points. So find the equation of the line passing through the following 2 points. PQ, P shall be, I don't know, -2, 1, and Q shall be, I don't know, 3, -1. Find the equation of the line passing through these 2 points. All right, so basically, what are we looking for? What do we want in this problem? Answer, we want the equation of a line. We want y is equal to ax plus b. So the very first thing that I will do is to find what a is. A is the slope. That's delta y over delta x. So y2 minus y1 divided by x2 minus x1, vamos. Doesn't really matter what you choose to be your point number 1 or point number 2. The answer in the end will be the same. So let's say this is x1 y1 and this is x2 y2. So we shall compute y2 minus y1 over x2 minus y1 in the following way. -1 minus 1 over 3 minus -2. That would be -2 over 5, and that is our slope. Very good, very good, very good, very good. So what shall we do now? We shall find the value of the y-intercept. How shall we find the value of the y-intercept? It's pretty easy. We are going to rewrite the general equation of a line, and we're going to replace a point in there, right? So, I don't know, let's pick the first point where x is -2 and y is 1. We know the slope, -2/5. We have the x value, which is -2. And it is by solving this equation that we will find what b is. So 1 equals 4 over 5 plus b. Bring this over. 1 minus 4 over 5 is 1 over 5. And that's my y-intercept. And that gives us the final answer for this problem. Conclusion. What is the equation of a line through these 2 points? The equation of a line is y equals ax plus b, where a is -2/5, so -2/5 x, plus the y-intercept, which we have found to be 1/5. Sounds good. So, little exercise to get the rust off our wheels. So, let us see if we can find something perhaps a little more challenging. So, example 2. Again, 2.5 stars. Find the equation of a line. Find the equation of a line parallel through the line of equation to the line of equation. What shall we have here? -2y plus 4x minus 7 = 0. And passing through the point, and passing through the point, what shall we get? Let's get something like this, 1, 0. So find the equation of a line parallel to the line of equation minus 2y plus 4x minus 7 is equal to 0, and passing through the point 1, 0. All right, good. So again, what are we looking for? What do we want? What are we looking for? What does the question call for? It calls for to find the equation of a line. That is y equals ax plus b. So on my agenda, the first thing is to find a, the slope. Now my line actually will be parallel to the line given here. So two parallel lines have the same slope, right? So if I can find the slope of this line, I will actually find the slope of my line. So let's investigate the slope of this. The slope of minus 2y plus 4x minus 7 equal to 0 is, I need to do what here to find the slope of that line? What do I need to do? I need to isolate the y and put it into y equals ax plus b form. So minus 2y equals minus 4x plus 7, right? If you bring the 4x and the minus 7 to the other side, they will switch signs. So y shall be minus 4x over minus 2 plus 7 over minus 2. That is to say y equals 2x minus 7 over 2. The minus 7 over 2 is not relevant here. What actually matters is the slope of this line, which is 2. So you know what that means? It means that our slope is 2 because the lines are parallel. Good. So we found A. Now we're going to find B. By following the same method as we did for the previous problem, we're going to write down the general equation of a line. And we're going to replace one point in there, whichever point we have. We have only one, which is the point 1, 0. So x is 1 and y is 0. So x is 1 and y is 0. And my slope is 2. So 2 times 1 is 2. Bring it over minus 2 is my b, which gives me the final equation of the line that we were looking for. We have a slope. We have a y-intercept. So the slope is 2, and the y-intercept is minus 2. And that is, again, a fairly trivial example. All right, what else do we know about points in the Cartesian plane? All right, so other notions. So other notions of analytic geometry. What can we do with points in a Cartesian plane? Well, we can talk about several things. The first one is the midpoint. All right. Oh, let's recall the points that we had before. Recall that we had P to be x1, y1, and we had Q to be x2, y2. If you recall this, then the midpoint, BTW, between P and Q is given by the following formula. You might remember that the midpoint is what's halfway. The best way to find halfway is to find the average. So I'm going to add my x's and divide by 2. And then I'm going to add me y's and divide by 2. And that's the midpoint. We'll practice this on some points in a second. Before we practice a couple of other notions of interest, the midpoint and then the distance, between, again, BTW, between P and Q is given by, oh, you may remember this formula. It actually comes this formula is actually derived from the Pythagorean result, from Pythagoras' theorem. And it goes like this: y2 minus y1 this time. Remember, for the midpoint we used to have a plus. Here the Pythagoras actually says we should minus the coordinates and square them. And same thing for the x. So y2 minus y1 squared plus x2 minus x1 squared. We call this little d for distance. And finally, the Pythagorean theorem. Pythagoras theorem is also something that we can use here. And it goes like this. It goes a squared plus b squared is equal to c squared, where a, b, c are the sides of a right. Right means 90-degree triangle. So we all, I believe, recall to a degree that old picture we saw several times in high school, where this is A, this is B, and this is C. And this guy bears the name, the infamous name for some of us, of the hypotenuse. Hypotenuse, hypotenuse. These are just the adjacent sides in the right triangle. It's a right triangle because it has a 90-degree angle right here. That angle here is 90 degrees. So the side opposite to the 90-degree angle, that's the longer side, and that's what we call the hypotenuse. Let us practice a couple of things on this. All right. I'm sorry if I am going a little fast on this. You can always stop that video at home. I just want to make sure that I have the time in a half-an-hour video to cover everything. Exemple 3. Exemple 3. I don't see how I can give this example more than 2.5 stars. So I prepared something here for us. Example 3. Consider the point P, which is minus 9, 3. The point Q, which is minus 3, minus 9. And the point R, which is, where is my point R? 13, comma, minus 1. So I have 3 points in here. I want, so find A, the midpoint between P, midpoint between P and Q. So midpoint between P and Q, that's P, that's Q. So what's going to be the formula for the midpoint of P and Q? Remember, that formula is the sum of the x's divided by 2 and the sum of the y's divided by 2. So we apply this here. This is my x1, this is my x2, y1, y2, vamos. So midpoint is, big bracket, sum of the x's divided by 2, minus 9 plus minus 3 divided by 2, comma, sum of the y's, 3 plus minus 9, I should put a bracket here to be consistent, divided by 2. Qu'est-ce que c'est? Minus 9 plus minus 3 is minus 12 divided by 2, minus 6. 3 plus minus 9 is minus 6 divided by 2 is minus 3. And that's the midpoint. And that is the midpoint. I could actually sketch this, maybe I will in a moment, these points in the plane, and then I'll show you that this actually lands smack in between the points P and Q. If I have the time, I'll do it. B. What could I find here? I could also find the distance. Of course. Find the distance between P and Q. Find the distance between P and Q. If you remember on the previous whiteboard, we had this formula for the distance. Differences of the y's squared. Don't forget the square. Because if you do, you might have a negative square root and nothing works. Plus x2 minus x1 squared. So distance equal big square root. Difference of the y's between P and Q. So minus 9 minus 3. That's just a dot here. And square, right? Difference of the y's, minus 9 minus 3. Difference of the x's, minus 3 minus 9. Qu'est-ce que c'est? That is the root of, hey, minus 12 squared. Plus, that's minus 3 plus 9, that would be minus 3 plus 6. I'm sorry, minus 3 plus 9 is 6. 6 squared, so that would be the root of 144 plus 36. That would be the root of 180. Good, we can most likely simplify this a little bit, but I'm not too sure that I want to do that. So just to give you like a quick overview, if I, in the Cartesian plane, if I actually sketch where the points are, I'm going to go by 2 here, minus 2, minus 4, minus 6, minus 8, minus 10. And I'm going to go here 2, 4, 6, 8, 10, 12. And I'm going to go here minus 2, minus 4, minus 6, minus 8, minus 10. I'm going by 2. And here 2, 4, 6 will be enough. So just to give you like a ballpark idea of what we are doing, the point minus 9, 3 would actually lie ballpark, minus 9, 3 would actually lie ballpark here. That would be my point P. My point Q is minus 3, minus 9, so minus 3, minus 9 would actually be ballpark here. So that would be my point Q. And then I would have a line that actually would go through this. And that line here would actually go through this point here and this point there. And what we have found here is that the midpoint, minus 6, minus 3, would actually be minus 2, minus 4, minus 6, and minus 3 would actually be here. That will be your midpoint. You see that it makes sense on this line, right? That it's the midpoint between the two. And also, we have found that this distance here, that distance is actually equal to the root of 180, which by the way, can be written as, what is that, 45, 6, that's 45 times 4, and that would be 9 squared, no, I lied, 3 squared, so 9 times 5 times 2 squared. Why am I doing this? Because I just want to show you that it is also possible to write the root of 180 as 3 times 2, 6 root 5. Now, that's not super important for here, but just in case we're stumbling on a problem in the textbook that has the answer on the back of the pages, and we're looking for a similar problem, and they give us the answer to be this, 6 root 5 instead of root 80, it would be nice if we could actually make the bridge between the two. Good. Good. All right, so ça c'est bon. Ça c'est bon, ça c'est bon. So maybe one last example with the time we have. Let's call that example 4. And I think that finally we can hike this up to potentially 3 stars. So example 4, 3 stars. I do believe we have the same points here. Yes, it's the same points. So the question here is the following. Do the points P, Q, and R, do these 3 points form a right triangle when we join them? A right triangle, remember right triangle means 90 degrees. Right triangle when we join them. So when we join these 3 points, do we actually get a right triangle? Well, we could try to draw this situation on a Cartesian plane, but it would probably just be like a visual aspect. Oh yeah, this angle, it could look like it's 90. Is it really? We're not going to use a protractor or anything like this. We're going to use the tools we have in analytic geometry. So if we have a right triangle, we know that this angle here is going to be 90 degrees, right? We know that for a fact. So what I suggest here is that we actually put our knowledge of the Pythagorean theorem to good use. Let us find the distance here between this point and that point. Then let us find the distance between this point and that point. And finally, let's find the distance between those 2 points that form the hypotenuse. And if a squared plus b squared equals to c squared, if indeed the Pythagorean theorem is verified, then we can say that we have a right triangle. Then yes, we have a right triangle. We have a right triangle. I shouldn't put delta like this because delta is difference. I'm just being lazy. Let's not be lazy. Let's write the word. The word is triangle. All right. So in order for us to verify this, we are going to calculate the distance between here and here, here and here, and there and there. In other words, what we need is the distance between P, Q. We need the distance between Q, R. We also need the distance between, what are the other 2 points that we haven't taken the distance between? Of course, the point would be PR. All right. So we've already done PQ, right, on the previous whiteboard, so we're not going to redo it. We're just going to use the fact that it is the root of 180. Distance between Q and R, this one we're going to have to figure out. Again, y2 minus y1, so Q and R. So let's do y2 minus 1 minus 9 squared plus, so minus 1 minus 9, and 13 minus 3. 13 minus 3. So what would that be? That would be what? Minus 1 minus 9. So that's minus 1 plus 9. That's 8. That's 8 squared. That's 8 squared. And here is 13 plus 3 is 16 squared. 16 squared. I believe I calculated that over here. And I do believe that I got the root of 500. Nope, that's not true. It's the root of 320. My bad. It's the root of 320, right? Right. And PR. PR is the first and the last. So difference of the y's, difference of the x's. PR, so minus 1, minus 3. Minus 1, minus 3 squared. Plus, what do we got here? 13 minus 9. That's going to be a big number. 13 minus 9, all squared. All right, that would be what? That would be minus 4 squared, so 16. So minus 4 squared, that'll be 16. And this dude is going to be 22 squared. And that's going to be the root of 500 if my calculations are correct. All right. So if these calculations are correct, then basically we should be able to find in these distances the following combination. One of them squared plus another one squared should be the last one squared. So check it out. Root of 320 squared plus the root of 500 squared. No, I lied. That's not the one that goes there. Mistake! It's the 180 that goes there. Root of 180 squared. That should be equal to the larger side, which is the root of 500 squared. Is this verified? Yes, it is, because the square root and the square cancel themselves. That's 320 plus 180, and that's equal to 500. So the answer is yes, P, Q, R form a right triangle. Good. All right, guys. Thanks for your undivided attention throughout this video. We have reviewed what we need to know to actually go into the next assignment, and we'll talk about this in class. So you take care, and I will see you soon. Have a good rest of the day. Ciao, ciao.